In text retrieval, full-text search refers to techniques for searching a single computer-stored document or a collection in a full-text database. Full-text search is distinguished from searches based on metadata or on parts of the original texts represented in databases. In a full-text search, a search engine examines all of the words in every stored document as it tries to match search criteria. Full-text searching techniques became common in online bibliographic databases in the 1990s. Many websites and application programs provide full-text search capabilities. Some web search engines, such as Alta Vista, employ full-text search techniques, while others index only a portion of the web pages examined by their indexing systems. Indexing. When dealing with a small number of documents, it is possible for the full-text search engine to directly scan the contents of the documents with each query, a strategy called serial scanning. This is what some tools, such as grep, do when searching. However, when the number of documents to search is potentially large, or the quantity of search queries to perform is substantial, the problem of full-text search is often divided into two tasks: indexing and searching. The indexing stage will scan the text of all the documents and build a list of search terms. In the search stage, when performing a specific query, only the index is referenced, rather than the text of the original documents. The indexer will make an entry in the index for each term or word found in a document, and possibly note its relative position within the document. Usually the indexer will ignore stop words that are both common and insufficiently meaningful to be useful in searching. Some indexes also employ language specifics stemming on the words being indexed. For example, the words drives, drove, and driven will be recorded in the index under the single concept word drive. The precision versus recall trade. Recall measures the quantity of relevant results returned by a search, while precision is the measure of the quality of the results returned. Recall is the ratio of relevant results returned to all relevant results. Precision is the number of relevant results returned to the total number of results returned. The diagram at right represents a low precision, low recall search. In the diagram, the red and green dots represent the total population of potential search results for a given search. Red dots represent irrelevant results, and green dots represent relevant results. Relevancy is indicated by the proximity of search results to the center of the inner circle. Of all possible results shown, those that were actually returned by the search are shown on a light blue background. In the example, only one relevant result of 3 possible relevant results was returned, so the recall is a very low ratio of 1/3 or 33%. The precision for the example is a very low 1/4 or 25%, since only one of the 4 results returned was relevant. Due to the ambiguities of natural language, full-text search systems typically includes options like stop words to increase precision and stemming to increase recall. Controlled vocabulary searching also helps alleviate low precision issues by tagging documents in such a way that ambiguities are eliminated. The trade-off between precision and recall is simple. An increase in precision can lower overall recall, while an increase in recall lowers precision. False positive problem. Free text searching is likely to retrieve many documents that are not relevant to the intended search question. Such documents are called false positives. The retrieval of irrelevant documents is often caused by the inherent ambiguity of natural language. In the sample diagram at right, false positives are represented by the irrelevant results that were returned by the search. Clustering techniques based on Bayesian algorithms can help reduce false positives. For a search term of bank, clustering can be used to categorize the document data universe into financial institutions, institution, place to sit, place to store, etc., depending on the occurrences of words relevant to the categories. Search terms or a search result can be placed in one or more of the categories. This technique is being extensively deployed in the e-discovery domain. Performance improvements. The deficiencies of free text searching have been addressed in two ways: by providing users with tools that enable them to express the search questions more precisely, and by developing new search algorithms that improve retrieval precision. Improved querying tools. Keywords. Document creators are asked to supply a list of words that describe the subject of the text, including synonyms of words that describe this subject. Keywords improve recall, particularly if the keyword list includes a search word that is not in the document text. Field-restricted search. Some search engines enable users to limit free text searches to a particular field within a stored data record, such as title or author. Boolean queries. Searches that use Boolean operators can dramatically increase the precision of a free text search. The AND operator says, in effect, do not retrieve any document unless it contains both of these terms. The NOT operator says, in effect, do not retrieve any document that contains this word. If the retrieval list retrieves too few documents, the OR operator can be used to increase recall. Consider, for example, encyclopedia, and online, or internet, not encarta. This search will retrieve documents about online encyclopedias that use the term internet instead of online. This increase in precision is very commonly counterproductive since it usually comes with a dramatic loss of recall. Phrase search. A phrase search matches only those documents that contain a specified phrase, such as Wikipedia, the free encyclopedia. Concept search. A search that is based on multi-word concepts, for example compound term processing. This type of search is becoming popular in many e-discovery solutions. Concordance search. A concordance search produces an alphabetical list of all principal words that occur in a text with their immediate context. Proximity search. A phrase search matches only those documents that contain two or more words that are separated by a specified number of words. A search for Wikipedia WITHIN2 free would retrieve only those documents in which the words Wikipedia and free occur within 2 words of each other. Regular expression. A regular expression employs a complex but powerful querying syntax that can be used to specify retrieval conditions with precision. Fuzzy search will search for documents that match the given terms and some variation around them. Wildcard search. A search that substitutes one or more characters in a search query for a wildcard character such as an asterisk. For example, using the asterisk in a search query, S**n will find sin, sun, etc. in a text. Improved search algorithms. The PageRank algorithm developed by Google gives more prominence to documents to which other web pages have linked. See search engine for additional examples. Software. The following is a partial list of available software products whose predominant purpose is to perform full-text indexing and searching. Some of these are accompanied with detailed descriptions of the theory of operation or internal algorithms, which can provide additional insight into how full-text search may be accomplished.